Thank you, Sham, for that didactic lecture. Now, I'd like to invite Mr. Ujjwal Jalgonka. Uh, so, Ujjwal has been kind enough to us. He has come from all the way from US, and he's probably giving us a talk on the Balt products. This is his profile. Ujjwal, I'm just going in. Can you hear okay? Please, Ujjwal. The stage is yours.
Okay. So if you can leave this slide up there, and I will just. So yeah.
This slide.
Go this one. And is my background there? No, I can just talk about it. Okay, so good morning everyone, and thank you to Dr. Kaushik for us to allow us to be here. Okay, yeah. I'll try to be here. So, okay. Please, again, thank you to Dr. Kaushik and everyone else who has organized this conference. I would definitely start by saying that this is a really unique combination of the Neurohackathon hardware conference, unique concept. I have been part of sessions where they have done it for a product specific, and then there was a whole deep dive on a product. But encompassing the whole product category and starting it at a little bit of a superficial level and then going in detail, it's a very unique concept because you don't get too many opportunities to do every product in a time, right? So really good initiative, and thank you everyone. Little bit about my background, we pulled that slide out, but I have been, I don't have the privilege of knowing somebody from Nagpur where I studied like Sham. He knows Dr. Kaushik. I didn't know anybody from Nagpur who is here. But I studied in Nagpur, Maharashtra. And I moved to United States for higher studies. I studied and have been in the medical device industry for about 20 years now. I started in cardiovascular, worked on the primarily on the atrial fibrillation, cryoablation projects, then moved on to some surgical technologies with Becton Dickinson. And then I have been in the neurovascular for last 10 years and with Balt for last 2 years. Wouldn't take much time to talk about Balt. I think I haven't made the transition to marketing yet. So I'll spare that talk about Balt to somebody who can do better job than me. So I will just go a little bit into the sheath and the products and feel free to ask questions as I go through it. It could be very primitive, or if there are more questions that are detailed, we are very okay with answering those questions. The content is tailored to how we thought we could move the information. So there might be a little bit of inconsistency in every one of us presenting. So bear with us. And so Sham, as you can see, my talk track might be slightly different than how you went through. So, okay. I was just going to start with just Ballast long sheath indications for use. The reason I put this here is that Ballast, all these products, they have unique indications in sometimes depending on the geographies, right? There is different regulatory requirements in different geographies, but this is the indication for is CE mark for Ballasts, which is what I'm going to talk about. Little bit of a high level of why Ballast. Ballast is a 88 long sheath. It's a single lumen braid reinforced variable stiffness catheter, and I can go into a little bit more detail on the construction of the device and why we selected those in the next few slides. This is something that you guys mostly know. It comes in 4 lengths, 80, 90, 100 and 105. And here I can take a pause and try to go into that question about why longer sheets. And again, Sham very correctly pointed out, we are catering to a global market, and yes, there are cases when that 105 might be used very seldom, but yes, that is the case where there is not a length and you are struggling for hours, right? And we want to make sure that we are capturing those ends as much as we can. Dr. Kaushik, you earlier this morning we were talking and you had asked like, do we get all the input and how do we make sure? We are not, we miss sometimes, but I think it is where we want to learn about like what can be improved. And with the Indian market where it is and more trained neurointerventionalists here, we are very interested in knowing this, and that's why we are here to learn more from you guys. So please feel free to give us suggestions on that. And then what does it come with? Our sheath does come with a peel-away introducer, a dilator, and we have both a hemostasis valve and a flow check valve. So you have the option of going with whichever way you go with. Little bit on the design. So sheath is a sheath is a sheath. There are little nuances. I think different sheath works in hands differently in different operators. One of the things that we looked at when we designed it was that we tried to have more transitions, and we focused very heavily on the distal section of the catheter. We are one of the, we believe based on the anatomic and how high the sheath needs to be in the cervical, and without getting a kickback, we did some anatomical measurements and we found the sweet spot to be somewhere between 9 to 11 centimeter. So when we say that 9 centimeter of distal winded coil followed by hybrid coil braid, and here is a nice picture showing that how this is a flat coil, and right around that 9 centimeter we transition over it with a braided construction. And why that is because in majority of cases you would want to have that distal portion straight up in the vessel above the arch, distal to the ostium of the arch, whichever vessel, great vessels you are going into, because otherwise you will start to see the fallback that will happen. And that sweet spot could be, some people can optimize it at like 6 centimeters, some can do it at 17 centimeter. It varies. There is no right or wrong answer. It is just the optimization problem. And then we do have a distal marker band, and one of the things that is very critical, and this was not very common for, in many cases for non-neuro devices, was not having a PTFE liner. Now you will see that PTFE liner is becoming a more of a requirement for sheaths because of the lubricity and the clearances that you guys operate your devices on. Quickly on the lengths and what skew matrix we are providing here. As you can see that we have a 80, 90, 100 and 105. The proximal OD is 106, so it very easily fits through any of your short introducers, whichever one you are using. I think if I recall it right, the smallest distal ID of a introducer is about 107. So we have tried to keep that 106 with that thing in our mind. We also realized that the distal OD, in order to go into the distal cervical, and many times when you, I don't know, somebody did bring up, I think, Doctor, you brought up something about having a cervical loops and 90 degrees and 360 degree bends. So we did try to make that distal OD smaller and more flexible. It is, again, a thicker pipe is more stiffer, so it's that same concept, making it a little bit more flexible and smaller. So we are one of the smallest distal OD sheath. And then the proximal ID is same through and through, 88. We also worked on the coating length optimization. We looked at, like, we didn't want the coating length to be so long that you are having the issues when you are operating on the proximal, but not too short such that you see the interaction with the vessel and you can feel it. So we have optimized it somewhere around 20 centimeter, and our hub length is 6 centimeter. One of the things that somebody mentioned is about the length on, lately the trend has been is that people have adjusted the whole stroke tool set to accommodate the longer sheath lengths. Again, like 165 micro catheters have become standard. Intermediates are 130 centimeter. So that is all the stack up calculations that you do with whatever maximum you do it. But yeah, there are times when you don't have, like if you were, there used to be micro catheters used to be 150 centimeter, and then there was a stack up issue with a 105 and a intermediate catheter. So those problems are like evolving, and we are all learning. Just like you, we are learning as an industry and getting that feedback. But that's 105 is, if you are choosing a 105, make sure that your whole tool set for stroke is matched to that. The two key attributes we say it about is like the distal getting there, which is 9.5 centimeter of multi-durometer distal coil segment. It is progressively softer, and it offers the smallest OD. One of the unique features is that a lot of sheets are designed with a coil versus a braid reinforcement, right? That's always a thing when an engineer thinks about, like, should I make a coil construction, should I make a braided construction? There are benefits of each of those. Coils do give you better kink resistance and ovalization, but you get a better torqueability with braided construction. So now that's where we are trying to, and better support. So that's where we have tried to balance it with a hybrid coil braid structure, and it is what we believe offers the better performance with Ballast. Braided reinforcement proximal segment is not just braid, but the coil goes all the way through the whole length, and then the braid starts on top of it. That just beefs up the proximal section when you're in the aorta, and it does not have a lot of snaking, if you will. Again, I'm reiterating myself, but a smaller OD for atraumatic navigation for radial access, we have seen a very good, we did, when we designed this sheets, we tried different model. This indications are in many countries access agnostic, but there are countries where they are becoming very, very particular about the recommendation on where you have tested and what is the design systems. We have done some testing, but in this market, like I said, there are markets where there is additional requirement to get this radial specific indication. We don't have that yet in those markets. Here it is, the testing has been done, radial has been something that this sheath has been used, and I'll show you some images of that. We do have long length available for radial approach. As I said, there is a transitions, 9 different transitions on mostly on the distal section, and as much as it is like an optimizer, you can have even more transitions and make it even better, but then there is a cost to it on like making those things repeatably also comes at a cost of, like, it's a balancing act of that. We did choose a soft coil for kink and resistance to ovalization. As you can imagine, when you are going through it, our intermediate catheter and sheath clearances are not significant. You're talking about 3,000-4,000 clearances. So even when you get an ovalization, you will start to see the resistance on those ones. So the distal section is where you will see those bends and all that. So that's why a coil construction for that. I talked about the extended hydrophilic length, coating length, and then we have a large ID. There was, I think the original Cook sheath was 87 or something. So 88 has become a norm. Industry is also wanting, as you pointed out, 96 is one of the largest sheath now. So, and then a dilator with a tip. This is just some of the images of what we were talking about, the radial use. We do see that you will see, even when you go from right radial to right common, you will see a very steep, sharp bend there, and we have seen very good results in the stability as well as any kink problems with these. Also, I wouldn't go through, this is just showing the images. You guys see it more often than we do, but we just had it here just to show that you'll see that it has the stiffness to straighten up a little bit, but then it rides up very well and not having a kink or something, which is the last thing you want. And then the fallback, as you can see, sometimes this sheath fallback when you are trying to push a flow diverter or something very far distal, and you are like, okay, I'm almost there, and the whole system falls back. So this system has a good stability at that, If you make sure that you are about 9-10 centimeter into the cervical or common IC, internal carotid, and you will see a very good results. I think that's pretty much it. Here is some publications that are again showing more acute angles of radial axis here. As you can see, pretty sharp angles. And then I would definitely agree with Shyam is that, and you guys know better, like higher the better. Of course, you don't want to cross the significant 360 loops with this. You guys have better hands at that. But if not, if you can manage to move the sheath as far as you can, that makes the whole procedure much safer. Okay, so that's all I had for Ballast. I'd love to get any questions or answer any questions. You are audible.
Put ballast in the radial section, and I wanted to know, do you recommend a short sheet that needs to be put in to track your ballast up, or it just tracks up very well even the radial without that?
When you say short sheet, like you need a dilator.
Okay, no. What we sometimes do is we put an 8 French or a 9 French, 8 French short sheet, and then we put this system across. Do you recommend that for the radial, because radial being a very small artery, or you just take the ballast up?
Is Kalyan around? Kalyan?
Kalyan sir is coming tomorrow.
Yeah, because I had the same discussion with the Kalyan, because putting an 8F sheath in the radial is technically difficult. So this is used as a sheath. You put a 6 French sheath and then put an exchange wire and use this as with a dilator, use the ballast as the sheath itself. So technically, if it's a small radial, taking this up becomes a bit difficult.
Yeah. So there is a lot of, and people have practiced it like different things. They give the cocktail, they dilate it, and anyway.
But even then, you can't use an 8F short sheath. Yeah. You can't use that.
So, usually, what they do is you use a 7F sheet to access, and once you are through, you take you exchange over a wire and remove the 7F and put the ballast in.
Ballast as a sheath itself.
Yeah.
With the dilator. It doesn't come with a dilator.
No, dilate, it comes with a dilator.
Yeah.
But now the short sheath, that is mostly the practice. Get an access with the 7 French and then go on. And that's why I was saying is that there is a significant requirement, and especially with the diaspora where your vessel sizes could be really small, you want to be very careful with any manipulation of the sheath. Even if you do an exchange, manipulating the sheath is still...
There is an increasing tendency to switch over to radial for all the procedures, including thrombectomy. So I think it's high time that the transition zone should definitely be different when you're using a radial catheter compared to a femoral. But I think using a catheter which is designed for femoral, for radial may not be the ideal thing to use. Probably the R&D should look into, because this transition zone in the origin of the great vessel should be different from what is there for the femoral. The length is different. So definitely that will straighten up the curve much more when you're using the same catheter for a guiding catheter for a radial use. So it's high time that, because everybody is looking out radial now. So it's high time that now you develop something specific for radial use.
We are certainly looking into those options. There are many options. One thing is that you want to make sure that you are not irritating the artery when too much manipulation here. Yeah. So we are looking at those options. There is a transition.
That becomes even more important when you are doing a left carotid from the radial, because the support in the arch of aorta becomes extremely important and difficult to navigate.
Yeah. And like you said that it's very difficult. One of the stacking up question is also about having most of you guys probably for radial use SIM2 shape, right? And those shapes, you lose a lot of length, so you only get so much to ride on, and so you need those very well said. And you are trying to optimize, so you are trying to find the balance, but is there a need for a specific design that really meaningfully changes your practice? I think that's to be something that we are looking to optimize it to a point where we just don't want to call it a radial sheath. We really want to see that you guys can tell us that, oh yeah, this is making a difference. It's not just saying that this is designed for radial. But that work is ongoing. Okay, good. Thank you. Okay, now just let me
Thank you so much for